Hello everyone, and welcome to my presentation, the 2D to BIM story, a better approach to concrete design and detailing. My name is Tomasz Fudala, and I'm the Technical Marketing Manager for Structure at Autodesk. In this first video, I will cover the differences between CAD and BIM. Be sure to check out all the videos in the series. CAD has been an important part of the AEC industry for decades. In the early 80s, CAD was a significant innovator that radically transformed documentation efficiency for the industry. CAD has also helped move the AEC industry far beyond manually produced paper drawings, enabling us to produce more complex and accurate designs. CAD programs are still in widespread use by engineers and detailers across the world. But today, the AEC industry faces new challenges. Financial constraints, for example, are placing the entire AEC industry under increasing pressure to deliver projects more quickly and accurately. As a result, AEC firms are looking beyond CAD to find a solution. Some of the challenges we are hearing include increasing project complexity can lead to inaccurate estimates due to a lack of design information. Detailers need a faster and more seamless way to collaborate with the design team. During the detailing phase in particular, data is often disconnected from the rest of the design team, leaving gaps in the project workflow. A lack of skilled engineers, detailers, and shop workers impacts quality, even across global teams. This places greater pressure on fabricators to automate their lines to increase output. A lack of job site coordination creates waste and inefficiencies. Fabricators are being asked to use technology to provide greater insight into how they will deliver and install building components. These are types of challenges addressed by BIM. Many of you may be thinking, okay, what exactly is BIM? BIM stands for Building Information Modeling, and it is an integrated process of creating and managing information for a built asset. It is a process for exploring project's key physical and functional characteristics digitally before it is built. The coordinated, consistent information used throughout the BIM process helps architects, engineers, contractors, civil engineers, and owners to see and understand prior to construction what their design will look like, and more importantly, how it will perform. Using the BIM process, the intelligent information informs the building process along the way. This visibility enables all members of the project team to contribute to its success through better coordination, improved accuracy, and the ability to make more informed design decisions earlier in the process. In recent years, the move from CAD to BIM has accelerated as BIM workflows have proven to deliver many benefits over CAD. BIM has rapidly evolved from a new technology to an accepted standard in many countries, and BIM guidelines are becoming increasingly common around the world. Now, let's take a quick look at one of the major differences between AutoCAD, a well-known CAD software, and Revit, a popular BIM authoring software. Naturally, this discussion could lead us down many paths, but I would like to start with the fundamental differences in the workflow. With all its tools and sophisticated features at its core, AutoCAD is essentially a digital drafting board. It doesn't fundamentally change the basic drafting workflow utilized by many design professionals in any noticeable way. In other words, before you can create drawings in AutoCAD, you have to decide what kind of drawing you are making. Are you making a plan or a section? If you want to create a plan, you begin creating a series of lines and curves to represent your structural design specifically as a plan. You then need to repeat this process to create a section or some other kind of drawing that might be required. In some cases, You can copy and reuse parts of your drawings, but these copied elements are not connected to one another in any way. When changes occur to your design, you will have to update each drawing individually to reflect those changes. In Revit, the process is fundamentally different. Instead of drafting individual drawings, we build a single representation of our structural model. This model is created from a collection of well-known structural components, such as columns, beams, walls, slabs, foundations, and of course, rebars when it comes to detailing. Each of these elements has its own settings and parameters that an establish meant to represent. And the entire group of structural elements comprises a single model. This model may be viewed in plan, section, elevation, 3D, or schedule views as designed. And users may define rules for each of these view orientations to ensure they match industry and firm standards. It is important to understand that in Revit, these views are not separate drawings, but simply different way of looking at the same model. At a glance, it may seem that the AutoCAD and Revit approaches are similar, but the result is completely different. The use of a model-based approach in Revit means that when a change is made to any view, the change is immediately reflected in all views. The views cannot fall out of sync. They are simply live representation of the same model. Additionally, using a BIM-centric solution allows users to design and detail with clash prevention in mind to reduce clashes, both in the pre-construction and site execution project phases. Using a BIM approach with Revit, we create a federated building information model, an aggregated assembly of distinct models for each discipline, comprising a single, complete model of the building. A single federated model is useful for design coordination, clash avoidance, and clash detection, approval processes, design development, estimating, and so on. The individual models are maintained as a separate files with clear authorship and scope definitions, but they are able to be brought together as needed. These are the fundamental differences between AutoCAD and Revit. For many firms, these represent the primary benefit of using BIM over CAD. In the next section, I will explain the benefits of modeling reinforced concrete structures in Revit, so please check it out.